everybody. My name's James Thomas. I'm a developer advocate for IBM working in our cloud division. And I'm here today to talk to you about what I think is a really new and exciting way to run Swift microservices, Swift backend, Swift APIs in the cloud without having to manage or set up any infrastructure to be able to do this, right? No having to provision virtual machines, no having to create containers, no having to install Linux servers and all of that kind of stuff, right? And this might sound kind of impossible, right? You know, serverless or server-side Swift without servers. But I'm going to show you a new approach using something we've called serverless cloud platforms that allow you to do just that. And in the second half of this talk, I'm going to do some live demonstrations of taking some sample Swift code from a laptop and deploying it to the cloud to give you the skills and techniques to go away and kind of do this yourself. Now, at this point, as well as thinking that this sounds kind of impossible, right? Swift without servers, you might also think that it sounds unnecessary. You might think, I like my servers, I like my infrastructure, I like my VMs. Why would you want to take them away from me? Well, the reason is this, right? Servers kill your productivity. And you might not realize it yet, especially if you're new to backend development, but trust me, it's true. And I think by the end of this talk, you are going to agree with me that servers kill your productivity, and you're going to want to go back to your office on Monday or whenever you go back to work. And if you see any servers, you're going to want to set them on fire and be free forever of the tyranny of looking after infrastructure. So why am I convinced, right, that servers kill your productivity? Well, imagine you have a Swift developer, right? So you're building a mobile app, and you've heard about server-side Swift. So you know you can now build your backend services and APIs in the same language as well. And you've got a great new idea for a new application. So you've finished the front end, you've done some Swift microservices, you're going to do the backend as well. And now you think, OK, I just need to deploy it. So you go to your cloud provider, you click a couple of buttons, you provision some infrastructure, you put your code on there, and then you think everything is going to be wonderful. But what you didn't realize is, as soon as you provision those first environments, those first VMs, those first containers, suddenly you've got all these extra tasks to take care of, right? If you're using things like VMs, you have to set up and manage those Linux environments. You've got to keep them updated as new updates to the operating system come out. You've got to get your middleware on there. You have to monitor that infrastructure in production, make sure it's healthy and up all the time. You also need to think about security, right? Is it backed up? Is it encrypted? Is it secure? Is it GDPR compliant these days? You need to think about scaling. Have you got enough capacity? Have you got too much? And after a while, right, I think if you are new to backend development, it can feel like you are held hostage by your infrastructure. I want to spend, especially with a Swift developer, I want to spend it in Xcode writing Swift and actually spend way too much of it kind of hunched over some cloud provider's VM trying to fix some kernel panic production. And this is not really what I want to do. I just want to run my code in the cloud and not really have to worry about it. So the question obviously is what can we do, right? Maybe if you're a Swift developer, you're very excited about doing server-side Swift. But now I've depressed you all and said, actually, it's going to be a nightmare of managing all these VMs and containers in the clouds, and it's just going to be very, very difficult. Well, fortunately for you all, I'm going to talk about, I think, a new and exciting way to run software and Swift microservices in the cloud without having to manage any of that kind of stuff that we call serverless cloud platforms or serverless computing. And serverless cloud platforms are built as this next generation service that really allow you to run code in the cloud without managing infrastructure at all. So let me ask you, right? Let me kind of gauge the audience. Who, put your hand up. Have you ever heard of the term serverless before, right? I know at this conference, probably most of you now, because there's like a whole track on it. Keep your hands up. I didn't say put your hands down. You can keep your hands up if you have ever used one of these platforms, right? Has anyone? OK, so that's about a third of the room, which is about normal, right? So maybe you've tried it, but maybe this is new to you. Maybe this is the first time you've ever heard this term. And if this was new to you, serverless was new to you, and you were like, you read about it in Hacker News a lot, and you're kind of thinking about like, OK, why is this different? And you went to Wikipedia and you read what they say about serverless, you'll read things like this, right? That serverless cloud platforms, they run your code in response to events, they manage your compute resources, they allow you to build event-driven applications. And again, if you read this, you might want to stop and scratch your head and think, well, why is this different? All cloud platforms, all cloud services say they do these kind of things for you. But serverless is different, and it's different for a couple of reasons. I think the first reason it's different is that it shrinks the unit of deployment. So rather than having to wrap, when you write your microservices, your application, rather than to wrap it in a huge VM image or some container or some monolithic deployment package, you can actually push the raw function code straight into the cloud platform and have it execute on demand when API requests come in. And this is where the term serverless comes from. It doesn't mean that there's no server. Your code is definitely still going to run on a server. But from the developer's point of view, from my point of view as a consumer, all I have to worry about is your microservice code, your stateless functions. Everything else is handled by the provider. And that's where that term serverless comes from. Another difference about serverless, which I think is a big advantage, is how it handles scaling. So you deploy your serverless functions, and then they get started on demand to process requests as they come in, right? Rather than having your functions, your microservices sat there idle waiting to process requests, they get started in milliseconds by the platform. And if you get loads of concurrent API requests come in, you get 100,000 a second, all the platform does is just spin up the environments under the covers to be able to handle that traffic, what we call scaling horizontally. And it means that as a developer, again, scaling is now the platform's responsibility. Rather than you having to think, well, how big a VM, how much memory and CPU and disk space do I need to cope with traffic that might occur in the future, you can just push all of that to platform and just make sure you follow the architectural guidelines about building these stateless little functions. So it's another thing you don't really have to think about so much with serverless platforms. And as well as scaling up, right, to cope with loads and loads of traffic, serverless platforms also scale down. And they scale down to 0 because, as I said before, your code gets started on demand to process requests as they come in. It doesn't sit there idle. So if you've got idle time in your application, you've got no requests to process, it means that none of your code is actually running. And that's really, really important when we consider the pricing model for serverless. So serverless, like all cloud services today, is you pay as you go, right? And you get charged for the milliseconds that your functions are running each month to process those API requests. So at the end of the month, the cloud provider adds up all those milliseconds and sends you normally a very, very small bill for the amount of kind of resource you've used. But as I said before, right, your code is only running when you're doing requests, when you're doing work. So all of that idle time within your application, now you don't have to pay for it. And I think this is one of the first times ever with infrastructure in the cloud that you don't have to pay for idle time. And this can lead to some dramatic cost savings. I've seen many blog posts online of people talking about moving certain workloads to serverless and saving 95% off their monthly cloud bill because now they don't have to pay for any of that idle time within their application. They're only going to pay when you're actually doing work. So enough talking about serverless at like a very, very high level, abstract way, right? Let's actually show you the code. Let's actually show you how to use this with some sample kind of Swift microservices that I've developed. So if you do decide you want to go and try out one of these serverless cloud platforms, the first thing you need is you need a provider, right? You need one of these providers who's going to run your code for you and kind of execute it on demand. And serverless today is available on pretty much every cloud provider possible, right? It's not just, some people still think of it as very much an AWS technology. And actually, whoever your cloud provider is, I guarantee you they have some kind of serverless offering for you to be able to play with. To give you the history of where this stuff came from, if you go back, serverless is still relatively new. It first kind of existed back at the end of 2014 when Amazon launched a new serverless cloud called Lambda in September, August 2014. And it got really popular with developers. Developers liked this new service, and so all the other cloud providers thought this is a good idea. This is a new kind of paradigm, and we're going to kind of bring out our own services which do the same thing. So IBM has one called IBM Cloud Functions that came out in the start of 2016. Microsoft have one called Azure Functions that came out in around the same time. Google have one called Google Cloud Functions that came out around the same time. You can see the very original naming. But I pretty much guarantee you, whoever your cloud provider is today, they have some kind of serverless offering for you to be able to play with. But if you're like evaluating which provider maybe is best for you in your languages and your runtime, I think there's a couple of good reasons to look at IBM, so we're going to look at that today. IBM's offering is built on an open source technology called Apache OpenWhisk. So when we developed our commercial offering, we also open sourced the whole thing and gave it over to Apache, where it's kind of lived ever since. And both Red Hat and Adobe have come on board and adopted it as their official service platform. So it's got kind of nice multi-vendor support. It's not purely an IBM project anymore. And this is the technology that powers IBM's commercial offering called IBM Cloud Functions. And OpenWhisk has some really, really key benefits for me, especially for Swift developers. So the first, obviously, is open source, right? It's a full open source Apache project, which means that you can run the platform locally and test and development. You could deploy it yourself on-prem if you've still got some kind of on-prem stuff or private cloud, or you can go and use a hosted offering from someone like IBM or Adobe or Red Hat. It's the same kind of commercial, it's the same open source projects for all of those kind of different deployment types. And the reason that IBM decided to open source its serverless offering quite early on is that we think, because many of the others are still proprietary, is that we think if you're building in the cloud, you always have this fear about building on some platform or service and what happens in the future if it just goes away, right? Remember what happened to things like Pass.com, or they make it very expensive or they deprecate it. And so we think by open sourcing the platform and keeping it open source, that it gives you a bit more long-term security that if IBM were to go away tomorrow, you'd still have a way to run your OpenWhisk applications. The other nice thing about OpenWhisk, and especially which is going to be relevant for my talk, is the runtime support. So with serverless cloud platforms, you just push your code into the platform and it gets executed on demand. So it means you're beholden to the platform to give you support for the languages that you want to be able to use. And different providers support different languages and runtimes. So for example, Node.js, right? Node.js I think of as the first-class serverless language. Pretty much every platform out there seems to support it out of the box, and OpenWhisk is no different. Java and Python, they're also relatively popular for serverless platforms, and OpenWhisk supports a couple of different versions of those. So those three languages are very common. OpenWhisk has support for PHP and Docker and static binaries. I'm not going to look at too much of those the kind of runtimes today, because the one I'm really interested in is the one in the middle and the bottom, which is Swift, right? OpenWhisk has native support for Swift out of the box. So you can push up raw, uncompiled Swift functions into the platform and have them execute on demand. And the reason for this is that IBM has been heavily involved in Swift as a language since it was open sourced by Apple about 2 years ago now. We've been doing some of the cross-platform support on things like Linux. We've been doing things like Katora, which is a web framework, and we've been working on the language itself. So for us, it made great sense to, if we're working on this serverless platform, we want to add Swift in there because it's a language we're heavily invested in. And I also think it's great for mobile developers because it means that if you're doing Swift for the mobile apps, you can quickly write some backend APIs and services and deploy them to the cloud without really having to know too much about kind of broader infrastructure stuff. Now, whatever language you want to use, right? You use Node or Java. In this case, today, we're going to be focusing mostly on Swift. The question people have, if they're new to serverless, is, OK, so you tell me I just write my code, and then I push it into the platform executes it on demand. How does the platform know what to do with my code with an API request in? How does it call it? How does it pass the event parameters in? And they all kind of work the same way in that when you finish your code, right? So in this example, we're going to be looking at Swift. So imagine I have this big Swift file called mycode.swift. All you need to do to make it compatible for the platform is to add a particular function with a particular name, and it's going to take a particular kind of event parameters. And every time an API request comes in, your code gets evaluated, your Swift code gets evaluated, and it calls that function with the JSON serialized to a native Swift type, and whatever you return is going to be serialized back out as the API response. It's a very, very lightweight way to use serverless platforms, whether you use Node or Java or Swift. They all just rely on you normally having a particular function that gets called every time an external event or an API request comes in. So for example, this is what it looks like for Swift, right? I've got this big Swift file. This would be the function that I needed to have in there. You can see that it's a function called main. That's going to be the identifier that the platform knows. It takes a name parameter, which is a dictionary of type string any, and it just returns a dictionary of type string any. And you can obviously do whatever code you want in that function. You call other functions, other packages, libraries, and this is going to be your interface from the platform into your code whenever those events occur. Now, initially when we added Swift support into OpenWhisk, Swift 3 was the current version of language, and recently, or last year, they announced Swift 4, because it gets released every year. And one of the great features, I think, in Swift 4 was something called Codeable. So if you're not familiar with Swift, it just makes it much, much easier to deal with converting between native Swift types and things like JSON automatically. Swift is a kind of static language. So when we were thinking about adding Swift 4 support into OpenWhisk, we wanted to integrate really deep support for this new Codeable protocol. So this is what it looks like. For Swift 4 support, you can actually do really cool stuff like this, right? So you've still got a function called main, But you'll notice this time, rather than being passed in a kind of dictionary of string any, which is kind of like a generic type you use for things like JSON, having to do loads of optional null checks, you can declare like native Swift types, and the platform will automatically serialize and deserialize JSON to those native types when the event occurs. So if you're using Swift 4 on the platform, we've got deep support for what we call a codable protocol, which is, I think, a much more natural way to deal with JSON and Swift, and it makes it much, much easier, and you have to write a lot less boilerplate code and deal with static type checking and all that kind of stuff. So, we said we're going to look at Swift on OpenWhisk, right? You mentioned if you've finished some Swift code, you've added a little function handler to be called by the platform. The next thing you're going to do is you're going to use a command line tool to push your serverless functions or your function code from your laptop into the platform, and the platform creates what we call an action in OpenWhisk. So an action is just a name that we use for serverless functions in kind of like OpenWhisk world, right? And I think of actions as like sleeping microservices ready to be woken up to process API requests as they occur. So let's have a look at doing this now. Let me take some real sample Swift code from a laptop, push it up to OpenWhisk, and show you just kind of dynamically execute on the code and the kind of workflow that we go through to do this. So let me hide my laptop and then mirror my screens. Do that. OK, so I said that OpenWhisk is open source, so this is a GitHub repo if you're desperate to see how it works under the covers, or the Kafka and the Scala and all that kind of stuff. And you could download this. There's instructions in the README about how to run the whole platform locally in a VM or with Docker that you can use for testing and development if you just want to try it out, which is cool. But I think for most people using serverless, the best thing to do is go to a service provider and just start to use it without really having to worry about Docker or any of that kind of stuff. So the one I'm going to be showing you today is a service called IBM Cloud Functions. And essentially, this is IBM's service offering, and it's just a purely managed, hosted version of that open source project running in the public cloud. And if you sign up for a free account, like all service providers, you get a very generous free tier that you can play around with really without really incurring too much charge. But it's just that core open source platform that I've kind of already introduced. But wherever you run OpenWhisk, right, whether you run it yourself or you use a provider, you need to get your code from your development environment into that serverless provider. And the way you normally do this is there's a little CLI you can download and install, and the instructions are here that just allows you to create new serverless functions and invoke them on demand. So I use OpenWhisk like every day as part of my kind of advocacy stuff. So I already have the CLI installed. So I have this little command bxwhisk that I'm going to use to interact with that remote OpenWhisk platform. And I've authenticated and done all that kind of stuff, so you don't have to watch me do that. So I think let's walk through what I call the kind of hello world example for a serverless function, just show you the kind of workflow you might go through. So I have a little Swift file here, and you can see that it just contains one function, which is called main, which is obviously the function handler that OpenWhisk expects. It takes dictionary, returns a dictionary, and essentially what it does, it's like a greeting function. It just says hello stranger, or hello James, or hello Sally, depending on the event parameters it gets called in. So, this is like the hello world example, not super useful, but I'm just going to show you the development workflow you would go through. So if I want to create a serverless, an action in the cloud, I can just say, OK, bxwhisk action create. I give it a name, call it like hello, and then I give it a path to the source file because we push up the code, and it should hopefully work. And I can just list my actions to show you that it's working. You can see that. So you can see in my workspace, I've got now a service function, an action called hello, using the Swift runtime, which is correct. So I can just test it out. I can invoke it. I can say whisk action invoke hello. And hopefully what it should do is just spin up some environment somewhere using Docker, inject my code, evaluate my code, call the function, and then serialize me back out the response of that function to JSON on the command line. And that's going to be, they're running the code, Swift code, and then give me back the result of that execution. There we go, right? Took a little bit of time. The Wi-Fi is not great at the moment. And I can call this again, right? I can give an event parameters using -p. I can say, OK, James. And I could say, and it should give me back like, hello, James. Come on, Wi-Fi. Yeah, there we go. And I can say, like, hello, Sally. And, hopefully it should just work, right? I could call this serverless function like 1,000 times in parallel, and it's just going to work. I don't have to think about scaling and VMs and containers and all of that kind of slightly more complicated stuff. Oh, dear. OK, let's see. try that again. And it should hopefully, yeah, it just works. So I can call a serverless function as much as I want. I haven't had to set up no infrastructure, no servers in sight, right? Although someone manages them. So that's a very simple demo. Let's think of maybe something a little bit more realistic, especially if you are a Swift developer building mobile applications. So imagine that you're building a mobile app for a retailer, right? And this retailer comes to you with a brilliant idea one day that they want to integrate Bitcoin into their application. They want people to be able to pay using Bitcoin during the checkout process, right? Whether that's a good idea or not, that's kind of up to them. So a Bitcoin as a currency is very volatile. It fluctuates like almost minute to minute at the moment. So you can't embed Bitcoin prices in your product database as like static numbers. What you want to do is during the checkout process, do real-time conversion, right? So you're going to call some API to do real-time conversion and get the equivalent amount of dollars or euros in Bitcoin. You think this would be a good API that maybe could use serverless to be able to do. So I actually have the microservice to be able to do this that I'll quickly walk through with you. Pigmentize Swift. And I'll walk through the code quickly, then we'll deploy it, and we'll just show you how quickly you can turn that into an API. So you can see this is a little bit more realistic, right? I've got some real code here to implement this API endpoint. It still has a function called main, right? It's going to take a dictionary, return a dictionary. It's going to look for two parameters in the input dictionary. It's going to look for a currency and an amount, which obviously you want to convert into Bitcoin. Then what it does is it goes and makes an external HTTP request. So it goes using the Swift libraries. It goes and makes an API request to CoinDesk. CoinDesk is a Bitcoin wallet, and they publish real-time Bitcoin prices that you can access over a JSON API. Does a bit of conversion into a normal Swift type. And then if I go down the bottom, it just does a tiny bit of math to take the real-time Bitcoin price and convert that into the equivalent amount of dollars or euros and return that really, really easily. So now I've already finished the code. I can just say, OK, action create. Let's call it Bitcoin. And it's called conversion. Bitcoin. It's a conversion.swift, wasn't it? And what that should do says, OK, I've got a new action. That's good. I can check it's been deployed. And then we can invoke it, right? We want to test it out, right? So we're going to test it out to make sure that it's kind of working locally. Seems to work. So I can say, OK, invoke Bitcoin. I need to obviously pass in the parameters. So I need to pass in the amount. Let's try like 10,000 because Bitcoin's super expensive. And I'll just try US dollars. And hopefully this should just work, right? It's gonna invoke my function, which is gonna make the API request. It's gonna pull me back the JSON, do a bit of math, and it should give me whatever the equivalent amount of Bitcoin that $10,000 is at the moment. So I'll give it a second or two to hopefully come back while I have some water. So there we go, right? Bitcoin's got very expensive again. It's nearly $10,000 for a single Bitcoin. And I can try it with euros, or I could try it with pounds, and it's just gonna work. It's deployed, and I've tested it, and now I can start to think about kind of integrating it into my application. I'll wait for that to come back, and then we'll kind of jump on. Nothing like wonderful conference Wi-Fi to make you sweat. Okay, I don't know. Let's leave it at that. And if it still is kind of having issues, I'm gonna jump to the video and show you that. But it's working. It's there. I'm not had to set up any servers to do this. So let me do that. Once you've got your actions deployed, the next things to think about is, OK, that's great, but how are you going to integrate them into your mobile app or your other kind of client application? You're not obviously going to use the command line to invoke it programmatically. And OpenWhisk has a number of different ways to be able to do this. The first is using something we call the platform API. So the OpenWhisk platform has a very well-documented RESTful, just HTTP API that you can talk to. You can send a HTTP post to it to invoke functions programmatically, authenticated with your developer credentials. So any client application, any mobile application you can send an external HTTP request to, you can invoke your functions, your serverless functions, through the platform API. And actually, there's client libraries available for Swift and Node.js as well, where it makes actually the process of doing that much easier. You don't have to manually construct all the HTTP traffic and headers and authentication. And actually, you'll see when I'm using the command line, I type like whisk action invoke. All the command line utility does is make those HTTP requests over to the platform API. It's like a very thin wrapper over it. And you obviously have access to that. It's very well documented. But obviously, if you're building like public APIs, public endpoints, you want some way to be able to invoke your serverless function using some kind of external public HTTP endpoint, right? Not without having to share your developer credentials with the world. And OpenWhisk has two different ways to do this: turn your function into a completely public HTTP endpoint. The first is using something we call web actions. So web actions are essentially a little flag you can set when you're creating the action that allows the platform will generate a unique public URL that you can then access. That means that when you call it, it will invoke the serverless function, but it doesn't require any authentication whatsoever. So it's a URL on the platform that's unique to you that you can use just to invoke that serverless function without requiring any authentication. And this is really good if you need a way to process things like webhooks or chatbots, just some very, very simple, quick, or for testing, we can quickly flip this flag and turn it into a kind of public endpoint that you can access. But if you are building like bigger, more high traffic profile APIs, at this point, you're probably thinking, what about things like API routing? I want different serverless functions to be called on, different operations and paths and that kind of stuff. What about rate limiting? I don't want, people to call my serverless function too much. It will cost me too much money. What about authentication? I want users to be able to authenticate and provide me their OAuth credentials that I can use with third-party services. And if you use web actions, right, and you want to have any of these features, you would have to implement them manually yourself, right? You get access to the HTTP headers coming in, and you can look at them, and you'd have to work out some way to do routing and rate limiting. And obviously, that's not a very scalable approach, or it's not something you would use for a very big, high-traffic API. So the strategy or the pattern, if you're going to do serverless development, and you're building big APIs, is to use services called API gateways. All cloud providers have some kind of API gateway service in there as a kind of offering. And what API gateways allow you to do is define public API endpoints that then call private APIs and they kind of proxy the requests and responses back and forth. And you can use this with a service platform to create new API endpoints that then proxy the private platform API without exposing your developer credentials. And the great things about API gateways is that they can handle all of those features like routing, like rate limiting, like authentication as kind of services in the API gateway, and you don't have to think about it at all in your code anymore, and you can really, really just focus on the business logic. And this is the strategy or the pattern as you're going to use. If you're going to use serverless, you're going to build APIs, you're pretty much always using an API gateway to manage those external endpoints. So let's have a look at doing this now. Let's see. I wanted to take the little Bitcoin function and I want to expose it. Let's try it as a web action, and let's also try it using the API gateway service. And let's see if the cloud gods are praying to me and it's going to behave. So I'll go back to that and mirror my screen again. Let's see if it's been a little bit better behaved. So let's try the web action first. So I can let's look at my actions that have been deployed. And if I say, I'm going to say, rather than saying create, I'm going to say update because it already exists. I'm going to update the Bitcoin action, and I'm going to set that flag, web, to true. Once that works, I should be able to retrieve the URL. So I can retrieve details about that function, and I can say, I want the URL for the web action. And hopefully, it should give me back this little URL. So now what I can do is I can try and invoke that. So I have a little utility in my shell. I can make command line requests just by typing HTTP GET. I type the URL. I say I want back some JSON. And the way you pass parameters, obviously, is just use query parameters in the URL. So I need to pass in the amount. Let's do like 10,000. And let's do currency equals US dollars. And hopefully, now it's just an unauthenticated HTTP GET request. It's going to call my service function, and it's just serialized back out to JSON the results of that computation, right? So you can see, 10,000 US dollars is 1.07 Bitcoins. And it should just work, right? It works the same. New currency code, new currency, and things like that. And you can see it's just a normal, unauthenticated HTTP request. So web actions really, really quickly allow you to just flip a flag, and now it's public. Like anyone in the audience could start to call this and run up a huge bill for me. So the next thing we obviously want to do, if you're going to have this as a proper API, you want to have an API endpoint, right? You want to have a managed service. So an OpenWhisk comes built in, the open source project comes built in with an API gateway service, which is really, really nice. And you can type command line, things like bxwhisk API, create, delete, update, to define the routes and the parameters and all that kind of stuff. And that works, but I think it's more intuitive if I show you through the management console in IBM Cloud. I just think it just makes a lot more sense when you're kind of trying to understand how this works. So you'll see this is just the management console for OpenWhisk and IBM Clouds. And I have this little tab down the bottom called APIs, which if I click it, it comes to this page. And so I can say, create a Cloud Functions API. Okay, create an API. You give it a name. We'll call it Bitcoin for obvious reasons. If you have a domain, you can set it to use your domain. Otherwise, it will generate you one. And you can see now I can start to set up that routing we talked about. I can say, OK, I want to say, whenever you go to /Bitcoin with a get, call my action Bitcoin. No, call the action Bitcoin. Return me some JSON. And then you can see all those things I talked about: security, rate limiting, OAuth, CORS. These are just flags in your API gateway. You don't have to think about or handle this in your code anymore, which is really, really nice. And hopefully, if the the cloud gods are being nice to me, click save, and it should generate you a new URL on the platform that then you can call programmatically to invoke your serverless function. So it looks like it's worked. There's the root. Because I don't have a custom domain register, it's giving me a custom root on the API gateway. And I can do the same. I can say HTTP get API/Bitcoin, because that's the path I set up. Currency is US dollars. Amount equals like 10,000 again. And it should just work. Hopefully, I should get back almost the same, pretty much the same JSON. It should just say $10,000 is like X amount of Bitcoins, right? It's actually changed. Bitcoin, I think it's changed, right, in the time that we've been speaking. So super volatile, so this is a useful API. So you can see how quickly I've been able to take my serverless function, I've taken some Swift code that I've written locally, I've deployed it, I've tested it works, turn it into web action to test it out, and then using the API gateway service, I've been able to flip a couple of flags and turn it into a fully managed gateway service with routing and authentication without having to think about infrastructure or containers or any of the stuff that actually runs your code in the cloud. And it's an incredibly quick way to be able to often run code in the cloud without thinking or manage about infrastructure. It's very cheap. It has all these I think, really good benefits, especially if you are a mobile developer who maybe isn't used to doing backend development, but you can write some Swift. Now you can write scalable microservices. And if you've been listening to me, maybe you are as excited about serverless as I am. You're ready to go and try it out. You're ready to go back to your office, start setting fire to all of your infrastructure. But before you do that, before you burn all your servers, I think it's only fair to introduce you to what I think are some of the challenges of serverless development. I'm going to talk about two challenges. One is very specific to Swift on serverless, and one is slightly more general, because like all technology choices, it comes with trade-offs, it comes with constraints, and it's a choice, right? And it definitely has some challenges, some downsides. So the first thing to recognize about serverless is understanding the difference between what we call warm versus cold invocations and the effect this can have on performance of your APIs. So what is this? This is an inherent characteristic of how serverless platforms work. Well, when I was doing the demos before, you might have noticed this kind of behavior, right? It was a little bit more difficult to notice because the Wi-Fi was having some issues. But the first time when I've created my serverless function, the first time I invoke it, it always takes a little bit longer to return than any subsequent invocation. And that actually, although it's difficult for you to pick up, this is not due to bad network, Wi-Fi, or that kind of stuff. This is an inherent characteristic of how serverless platforms work. So why is this? And this affects Swift more than some other runtimes. Well, let me drop beneath the covers of serverless and very, very quickly, in 30 seconds, explain to you all the steps that need to happen for your serverless functions to execute in the cloud and what actually goes on beneath the rainbow. So when you type whisk action invoke, right, I said it just calls the platform API. But a number of steps have to happen before, obviously, you get the result of your code being serialized back out to JSON, right? It uses containers. They all basically use containers under the covers. Starts a container in milliseconds. It injects your code. Then, because Swift is a compiled language, it runs Swift build to generate your binary, calls the binary, executes your function, passes in the event parameters, and whatever you return is serialized back out. Now, rather than go through that whole process again, what it actually does is to improve performance for subsequent invocations. It will pause the container. It won't just get rid of them. It will pause it so it can reuse it for subsequent invocations to speed up that process. Now, this is where it affects Swift more than other runtimes. That Swift build step actually adds some initial delay if you're pushing Swift source code in. So the question you have to ask is this important for you, right? Does latency really, really matter? If you're building something like just a webhook endpoint, you probably don't really care whether the first one takes 3 seconds and the subsequent ones take a second. But maybe for some APIs, it's very, very important and latency is very sensitive. So there's a little trick you can do that work with all serverless platforms. especially around Swift on OpenWhisk, is that you can actually deploy the binary. You can run the Swift build locally, and you can deploy the binary, static binary, rather than pushing the source code and letting the platform do it. And that means that for cold invocations, the first time your function gets executed, actually you'll skip out that whole Swift build step, and it means that the cold invocations are much more performance enhancing. So it's something you can do. It doesn't affect, obviously, JavaScript or Python, which are evaluated languages. But for Swift, if we're concerned about cold start performance, generally we would always deploy the binary we've done locally. And then the second, so that's the first challenge, right? We're doing Swift on serverless. And it's very specific to compiled languages. The second challenge that you might run into is more general and applicable for any runtime. And that's this, that serverless computing platforms are very opinionated. Platforms are very opinionated about the kinds of applications they expect to run. It's for modern cloud-native microservices that like scale horizontally and are stateless and all that kind of 12-factor microservice stuff. It's not designed, you can't lift and shift legacy apps and throw them up there. You know, I don't think we have many legacy Swift apps today, but it's something to think about. And one of the ways that they enforce those guidelines, these choices on you, is by limiting access to some of your compute resources. And these are some of the kind of limits that OpenWhisk puts on place, but they're generally indicative of any serverless platform. They generally all work in the same way. And the big two you'll run into if you're not used to serverless development is the first one is around timeouts. When your serverless function is executing, you normally have a maximum of between 5 and 10 minutes, depending on the provider, to finish processing that request and return. If you don't, it just like kills it off, the process off, and returns an error code. And all platforms give you between normally 5 and 10 minutes to be able to process that request. So again, if you have some batch process that takes like 4 hours to complete, can't really use it on serverless platforms at the moment, but sometimes can catch people out. But mostly for APIs, it's very, very quick request response style processing. The other big limit you run into is around memory. Serverless functions they get charged for the milliseconds they're running, but also how much memory they allocate, and you can tune the maximum amount they're allowed to allocate to reduce the cost or improve performance, kind of your choice. But the amount of memory they can use is in like the gigabyte range, like 1 gigabyte, half a gigabyte, 2 gigabytes. It's not terabytes of RAM. So if you need some algorithm that needs like terabyte of RAM to be able to produce really, really quickly, again, it's not really going to be appropriate for serverless cloud platforms. Can't access GPUs at the moment or very, very specialized hardware. It's for quick, event-driven, kind of stateless functions that run on demand. But you know, it's really important to understand the limits of serverless. It's not for everything, and build your application architecture to kind of embrace those. Don't fight against them, because the platform always wins. So, I said at the start of this talk, right, that servers kill your productivity. And hopefully, maybe now you agree with me, right? All that time spent patching kernels and managing VMs and upgrading middleware is actually not time you're spending on what's important, on building your product, especially if you're kind of mobile developer, on listening to your customers and pushing out new releases or fixing bugs. And I think if you are a mobile developer or someone who's not used to backend development, you start to build stuff in the cloud, APIs, it can often feel like you get held hostage by your infrastructure, right? I want to spend time, writing Swift and Xcode. I don't want to spend it managing all these kind of sprawling VMs. So I want to encourage you, if you are maybe a mobile developer who's starting to think about doing API development at server-side Swift, right? Embrace this serverless revolution, right? Burn your servers, deprovision your VMs, delete your containers, and be free forever of the tyranny of looking after infrastructure. But more importantly, upgrade your productivity, right? Get back to doing what you love, which is writing code, not on kind of managing infrastructure in someone else's data center. So thank you very much for listening. If you want any of the resources from this talk, now's the time to take a picture of the slide, although I'll put them online later. If you go to the bit.ly link at the top, it'll get you to a GitHub repo with all the stuff I've talked about today. If you like OpenWhisk, and I've done my job, and you want to come and hang out in the open source community, and you've got questions, Slack's a great place to ask, because that's where we all are. And also Stack Overflow, if you ask on there, especially about Swift and OpenWhisk, you'll probably get an answer from me. Or if you need more help, more personal instruction, you can just tweet me at ThomasJ or at OpenWhisk, and someone will gladly come and help you. So thank you very much. I've kind of run bang on time, so I think we've got like a minute or two for questions, or I'll be around for another hour or two if I have to fly home. So just come and grab me. I'll talk about anything serverless related, apart from, it does use service. I've told you that. Please don't ask me that. So thank you very much. So yeah, if you have questions, you can put your hand or come to it. Otherwise, come and grab me later. Yeah, thank you. Is there any more? I don't think so. Any questions? Oh yeah, there's a question. I think I now have to.
My question is OpenWhisk or do you know also the other platforms are ready for I have this scenario. I want to put out my application fast, and so I use functions because you just code and use them.
Yeah.
And what if I want to transform some of the functions to persistent services to increase, for example, response time or whatever?
Yeah, so the question is, if you start using functions, you want to move to some kind of infrastructure, like is that easy? Yeah, I think that's relatively simple because you're still just building like functions. It's just a function, it gets called with an event. So you could easily take that code and wrap it in some other shim to expose it as some kind of other traditional web framework. Yeah, you're always building stateless functions. They get called with an event source. So it's very easy to move that code. It's not very tied to the platform. The only point you're tied is just that little function handler.
Yeah, maybe the API gateway. If I can still use the same API gateway.
You can. Yeah, you can still use the API gateway with So it's not just for functions. It's for any of the cloud services, and it's the same with all providers. The API gateway is a separate service. They have integration with functions because it works really well, but people use it for non-function environments.
Okay, thank you.
All right. Any other questions? All right, there's one there.
Hello. And what if my feature depends on some library? How can I install it, or I can't do this?
Yeah, that's a good question. Yeah, you absolutely can. So rather than pushing the source code, so if you're using something like Node.js or Python, you can deploy a zip file, which includes your Node modules or your pip virtual engine modules. If you're using Swift, you run the build locally, and then that binder will contain all of those libraries. So yeah, normally they come built in with some common libraries in the environment, so you don't necessarily always need them, but yeah, you absolutely can just deploy your own custom libraries or like NPM modules by just zipping it all up and then uploading that. You don't have to use a raw source file, or just use a raw source file. Okay, any other questions? All right. Thank you very much for coming. Yeah, if you want to talk to me about anything later on, just kind of come and find me or talk to me and follow me on Twitter. Thank you.